Hello, and welcome to Week 6 of Robotics for All's Fusion curriculum. This week we're going to learn about the process of assembly, which is taking various models you've designed and combining them into a finished product. In the video right now, you can see me designing the object I'll be demonstrating how to assemble. If you want to follow along, you can download the model from this link. The password to access this model is Robotics for All Students. Now, there's a few schools of thoughts on organizing files for an assembly. The method I'm going to use here involves designing objects in separate files, then bringing them into a single file for the assembly. The advantage of this method is that you can create each object in a clean workspace, and you have access to the entire history of that object's design. Another method involves creating all the components for an assembly in a single project file, then joining them. This method makes sure that you will not have any missing links if a component is moved or corrupted, but you may lose access to that component's history. In this class, we're going to be using that first method for assembly. That way you can clearly see and modify each component before and during the assembly. So here we have all the completed models for our lamp we're going to assemble today, but it looks like one of the arms is missing. We're going to need two of them. So first of all, I'm going to show you how to insert a component in here. So on the data panel on this side, you can see all the individual components. We have the arm, the base, the light, the nut, the screw, and the little name for it, as well as the file for our assembly. Now, if I want to insert a component from a different file into this file, it's very simple. All I need to do is right-click and click Insert into Current Design. So let me do that. And here we go. We have a second one here. Now, it's going to allow us to move it around, and it actually doesn't really matter where we put it because we're going to constrain them together to complete the lamp. So I'm just going to put it beside it right there. Now notice there's a chain link icon here beside every single component inside the hierarchy. That means it's linked to another file. So if we make a change in the original file, we can update the assembly to reflect that change. So I'm going to demonstrate that really quickly. If I go to this lamp arm file here, and let me just make a quick extrusion on this side. Okay, now I've made a quick extrusion and a change on our lamp file here. And notice, remember, we have access to the whole history of the file, so if I want to undo the change I just made, it's super simple. But watch, I'm going to keep this change here, I'm going to save this file. Then, when I enter the assembly again, you're going to notice that there's this exclamation mark here above both of the arm components here, and that means that there's been some changes to those models, so we need to update it. So there's a few ways we could do that, but the easiest way is to click this button right here. And it says, click here to update all out-of-date references. So these references are out of date. We click it, and you'll see that they will update with that new little extrusion I made. Now, we don't really want that extrusion on there. It's not very helpful, so I'm going to go ahead and remove that. And you'll see if I remove that here, and then save my lamp file again, come back in here. Once again, they're out-of-date references, so we click it, and they go back to normal. Perfect. With all these components designed and laid out, I can now show you the different tools we use to assemble the components together. And in case you didn't know, the difference between components and bodies is that components can be freely moved because they have their own origin and degrees of freedom. So all these pieces here are components because I can grab it and move it around freely. When we insert another design into a project, it's going to automatically become a component, and so we can manipulate it as a component. Now, when we want to assemble the different components inside of a model, we want to go to the assembly menu right here. So there's a good number of tools here, so we're going to go one by one. So new component will create a new empty component, like I mentioned before, which you can use to create another model and make sure it's a separate component to the other components that might be inside your project. But in this case, we don't need to use that. The ones we're really looking at today are going to be joint and rigid group. So a joint is a tool that is used to connect two components together with some sort of particular behavior. A rigid group is similar, except it makes sure that their positions relative to each other are locked together. Okay, now we have all of our pieces here in place, so we can now assemble our lamp model. So the first step we're going to do is we're going to go ahead and look at the base of the lamp here. This is the lamp base component. We can find it in our hierarchy right there. So this is going to be the base of our component, so what we want to do is we want to ground it. So I'm going to click the ground option right here. I could also right click on it in the canvas as well and click ground. And what that's going to do is it's going to lock this piece in place so it can't be moved. And you can see it's grounded because of that little pin icon right there. So it's important that we ground this piece because we don't want the base of the lamp to move at all. This is going to be a solid location where we can constrain everything else too and it won't move. The next thing we're going to do is we're going to take our lamps component here and we're going to constrain it onto the front side of our lamp base here. So what I'm going to do, go to the top view here, get the move tool, and we're going to make sure we can select the entire component, so not bodies, components. And now I can select this whole piece here. I'll use the square so I can drag it around, and I'll move it just here. There you go. Okay, now I'm going to check on this side. Let's rotate our view here. Alright, yeah, we wanted to poke out just a little bit, so I'm going to drag it up. There you go. I'm going to click OK to confirm it. There you go. Now we've moved that lamp in place. But remember, we've only moved it. We haven't constrained it yet. So that means if I grab it, I can move it around, and that's not good. So we want to constrain it together. So how do we do that? Well, we're going to go ahead and use the rigid group tool here. It's going to lock the position of our lamps to the position of the space. So rigid groups. So because we moved the lamp around, it's going to ask us if we want to capture the current position or continue in the previous position. So what we want to do is we want to click capture position, and that means it's going to update the positions from what they were before to what they are now. Okay, now we can select the components we want to become rigid groups. So we want the base to be in a group with the lamps. And click OK. And now they're grouped together. So you're not going to see any visual change, but you'll notice that I can't drag the lamps around anymore. And the reason is remember, our base is grounded, meaning it can't move. It's fixed in space. And because we've put a rigid group between our lamps and the base, it is now also grounded in place and cannot move. Okay, now we're going to go ahead and use the joint tool to assemble the rest of our lamp right here. So first thing I'm going to do is I'm going to attach this first lamp arm to it. So I'm going to go up to the join tool. The shortcut is J. Now I'm going to use the joint tool to attach our first arm to the lamp base. Now notice that this is grayed out, and that's because the first component you select of the joint tool is going to be the one that moves. And because we grounded the lamp base, that means we can't move it. So the first component we'll select is the lamp arm. So I'm going to select this face, or this open hole right here, and that circular icon you see, it represents the joint origin. So when the joint is made, the circular icon that I select here is going to be aligned with the circular icon on the second object. So see how that icon appears again? Those two are going to be lined up. So you have to make sure they're going to be in the right place. Alright, now when I click it, see it drags into place. Now that it's in place, we need to take a look at what type of joint we want. Currently, if you go to the motion category, it's set to rigid. And just like the rigid group tool, that means it's not going to move. It's rigid, it's stuck in place. But we don't want that, right? We want this lamp to be able to move and be able to be pushed around. So instead, I'm going to select Revolute. Now, hey, that looks pretty good, but there is that issue where it seems to be going through the lamp base, which realistically is not possible. So let's go ahead and first confirm this joint tool action. Okay, great. Now, if I try moving this lamp, you'll notice it is now constrained. It can only move in that one rotational axis. But it can still be inside of the lamp base, which is not what we want. Luckily, in Fusion 360, we can create a joint limit for this revolute joint and make sure that it can't interfere with itself. So I'm going to go ahead and right click here and go to Edit Joint Limits. I can also edit the joint limits from the timeline here. So I'm going to click Edit Joint Limits, add a minimum and a maximum. And now what we can do is we can drag each of these arrows to set the two different minimums and maximum positions. And that blue area you see appearing inside the joint, that's showing you the area that's going to be able to be moved. So in this case, I'll set this joint to be right about there. Now to set the minimum position, we'll set it a little bit further back. That. Okay, so now that we've added these joint limits, you see our top of our lamp can move properly. Okay, the next thing we want to put in there is one of these screws. So these screws, they're going to have to be joined all the way inside this hole here, as if you were actually making this, you couldn't just put the lamp arm in there, you had to have something to hold it all together. So that's what this piece would do. Okay, so we're going to go ahead and use the join tool again to join our lamp screw into the base of the lamp through this hole right here. So we're going to select the position like we did before on the first component, and in this case I'm going to select this ring right here. Okay, great, that's the first position. Now the second one, I want to put it right through this hole here, so I'm going to select this edge. And you'll see they are slide in, and there you go. So Fusion 360 remembered what type of joint I did last time, which was the revolute joint, but that's not exactly what we want here, right? We want this to be able to slide in and out. So in this case, we're going to use the cylindrical joint. Now there is a joint called a slider, which looks to be right, but if you notice, this screw is threaded. That means it has these threads running along the front of it, and in reality, if you wanted to remove this, you're going to have to screw it. You're going to have to spin it. So in this case, we're going to use the cylindrical joint. The cylindrical joint will allow the object to translate along a singular axis while also rotating. So that's actually what we want in this case. All right, I'm going to click OK. Now we have this screw in that looks great, but uh-oh, that does not look good. We need to make sure the joint limits are set correctly. So let's go ahead and do that. Okay, I'll do it from the timeline. I'm going to do edit joint limits. And because there's two different axes of motions here, there's rotation and translation, you can actually change which one you're editing the joint limit for. So in this case, we don't really need a limit for the rotation, so we're just going to go directly to the slider, and we're going to add a maximum. All right, and a minimum too, so it can't go through. So we're going to go ahead and take that maximum, and we're going to put it out about this far. Okay, then we click OK to confirm the joint, and there you go. Now we can properly pull our screw in and out while rotating it as well. That's awesome. All right. Now we also have these nuts here that we want to attach to the other side of the screw to keep it held in. So I'm going to use the joint tool again, and we're going to select this ring right here. I'm going to place it up against this ring right here. Let's see. Okay, that looks pretty good. Now, once again, because this nut is threaded, I think a cylinder joint is quite appropriate for it. It allows it to spin and be pulled off of the other screw. So let's click OK. But once again, we have that pesky joint limit issue again, so let's go ahead and set that. Edit joint limits, minimum and a maximum. And then we want to remember, oh, see, I forgot to change this. So we set a minimum and maximum for the rotation, but we don't really need that, right? We want to be able to rotate as much as possible. We only need to set the limits for the slide. So I'm going to activate that, activate a minimum and a maximum for the slide, and drag the maximum out here. And there you go. Now we can properly rotate this and slide it in and out. All right, there you go. Now we have the first bit of our arm for our lamp constrained. We can move this around, and we can rotate and spin this out, as well as the nut, which is good. Now let's go ahead and start constraining the other lamp arm here. So what I'm going to do is I'm going to go back to the joint tool, capture position. Now this will be the same constraint as our other arm here. So in this case, I'm going to make it a revolute. Go to second option, revolute joint. All right, now I'm going to change up which face I'm going to use. I'm going to use, oh, I need to restart the tool there. Capture position. All right, I'm going to use this ring right here instead. Okay, and make sure we're on a revolute joint. All right, for the second component, we're going to select. Now let's see, we chose that inside face there, which is going to be up against this one here. So I'm going to go in here and click on that. There you go, that looks pretty good. Oh, but it looks like we're having some issues there with the joint limits once again, so let's go ahead and jump in there to fix that. So we go ahead and edit joint limits. We're going to add a minimum and a maximum. And we're going to turn this one all the way around. It's just about like that. Let's see if that looks right. Yeah, it looks pretty good. Okay, now we're going to set the maximum as well to be all the way back there. That looks pretty good. I click OK. All right, now we have both segments of our lamp's arms here, and you'll notice Fusion 360 is really smart when you have multiple joints. So you can move them just like the motion would expect you expect to have in real life. So here you can see me realistically moving both the joints on the arm like that. Pretty neat, isn't it? All right, let's go ahead and put in these other components here. Now, in reality, if you're CADing this for somebody else to design and somebody else to see and discover how your thing works, you might not want to have a cylinder joint on every single one of these, right? Maybe just one so you can demonstrate its ability to be removed. But on the other ones, perhaps you want to keep it just in place and have it not be able to be moved. So in this case, we're going to use a rigid joint here. So we're going to use a rigid one. I'm going to select the first component, which will be this face again, right there. Okay, now we're doing this middle one here, so I'm going to put it on this side. All right, and that little shaking animation shows you that they're locked together. Okay, and then I want to put the nut in as well. Now look at that, that's a strange issue. When I try to join them together, it looks like the nut is inside of that top clasp on the lamp arm. So that means I need to select the other face of the nut as I'm trying to constrain it. So the top face of this didn't seem to work, so I'm going to go ahead and go back into the join tool, and I'm going to, a neat little trick if you have a cylindrical thing here, what you can do is you can hold Alt on your computer, and you can shift between the different faces of that particular feature. So in this case, we're going to select the bottom one instead of the top. Okay, and now we go back over here and we click here. And there you go, now that looks like it's locked in place. Now remember what I said about these joints, they only lock movement relative to each other. So even though I've placed a rigid joint on these, they're still going to be able to be moved by the whole thing. Rather, they just can't be moved relative to each other. So the whole object can be moved, but these will not be moved. Okay, now it's time to put in the final bit of the lamp, which is the actual bulb itself. This is going to be very similar to the other lamp base. I'm going to go ahead and join tool. Now this one should also be able to rotate like the other lamp's arms, so it's going to be revolute. I'm going to select the first component, and I'm going to use this interior face there. Alright, so then that interior face, let's see, over there, so it should be this face right here. There you go, that looks pretty good. Alright, now what we want to do is we want to set some joint limits, because it almost looks good, but your lamp can go inside each other, which is really probably can't do in real life. Unless you have a really special lamp, that is. Alright, so let's go ahead and edit joint limits here. I'm going to add a minimum and a maximum, and then I'm going to rotate this all the way around. That looks pretty good. And this one I'm going to rotate down here. That looks pretty good too. Press OK. Now we got proper joint limits set up. So if we take a look at our whole model here, oh, let's not forget this last screw though. I'm going to go ahead and put this in as a rigid joint as well. Okay, now we have both of the third and last screws and nuts attached. So now if we take a look at our entire model here, it's looking pretty, it's looking pretty good. And now we can actually properly move it around here, just like you would be able to manipulate maybe a desk lamp or something similar with all these little bits here. Alright, that looks pretty good. Once you finish designing a model and assembling it, what if you wanted to create a high-quality image of your creation? Fusion and many other modeling programs has a workflow for that called rendering. In order to render an image in Fusion, you need to change your workspace into the render workspace. So you can come up here to where it says design, and we're going to go down to render. Okay, ooh, look at that. So you can already see that it's rendering the image of our lamp in a slightly higher quality version here, but we can have even more control over it. And before we do that though, let's go ahead and try to edit the material and appearance of our model and then render the final image. So when you click the appearance menu in this little color wheel here, you're going to see a menu of all these kinds of materials and colors you can apply to your model and give it some unique appearances. So in this case, I'm going to go ahead and make it out of aluminum, which is a pretty common metal that you might see something like this made out of in real life. I'm going to go for blue and red because that looks cool. So I'm going to put blue for the lampshade there, and I'll make the arms red. So you can just click and drag it off of this browser and put it in here. So now that once you have your materials properly set up on your model, you can go ahead and click this teapot icon up here to render an image of your model. Now there's two different ways to render it. You can do a cloud render or a local render. A cloud render is going to render it using an external server. So if you have a student account attached to your Fusion, you should be able to render this unlimited number of times as a cloud render, and that way you won't be taxing your local hardware. Otherwise, you can use a local renderer, which will render it on your computer itself. Now normally when we render an image, we're going to go to web mode over here. We're going to choose 0.8 megapixel, and then you make a choice between cloud render and local render. The render quality between standard and final just determines how long it's going to take to render and how much detail are they putting into it. So in this case, we're going to go ahead and render an image using standard quality as a cloud render. And you see it gives you an estimated time less than 10 minutes for it to render. Alright, when everything's set up and you're ready to go, you can go ahead and click this render button. And you'll see inside your rendering gallery here, it's going to start the process of rendering it. you'll see a bar appear, and that's going to tell you when it's done. So we're going to go ahead and wait for this render to finish, and we'll see what the final image looks like. Okay, our render is finished. We can click on it, and you can see the high quality image of our object. Maybe next time we could get a little bit closer for that so the object's bigger, but as long as you move the camera around inside here, inside the scene, you can get it to be as close as you want to the object, and you can change the angle, and you can make sure it looks exactly how you want it to be here. And you can even manipulate it like that if you wanted to change its position. But yeah, that is how to render and assemble your objects in Fusion 360. I hope you enjoyed the tutorial, and if you want to save your rendered image, you can go ahead and click this button right here to download a copy. Thank you so much for watching, and have fun in class.